Okay, here is a first review sheet. So it says use an integer to represent each situation. State what 0 would represent in each one. So profit of 300, that means you earned $300, so it'd be positive 300 or just 300, however you choose. And what 0 would represent in this situation, if you had a profit of 0, you made no money, right? You didn't make anything. 45 feet below sea level is negative 45, and 0 would be you're on the surface of the water, or you can write you're at sea level. Okay. When back 10 spaces would be negative 10, and 0 means you stay where you are. You're not going forwards or backwards. Stay where you are. Goes up 12 floors. You went up 12 floors, so it's positive 12, which means 0 in this case would be you stay on the floor that you're on. Stay on your current floor, whatever that is. Okay, doesn't mean ground level. Okay, so it means that you are on your current floor. So you could have been on the 5th floor, you know. Okay, and next one, find the value of each expression. It's absolute values. Let's find the absolute value of negative 4 is 34 because you're 34 units away from 0. The absolute value of 14, well, there's a minus sign here, which we're not going to get rid of. We're just going to write the minus sign there. And then we're going to take the absolute value of 14. And the absolute value of 14 is 14. So your final answer is minus 14. Before you add these two, please take the absolute value. So the absolute value is 5 plus the absolute value of negative 7 is 7. Now that they're just regular old numbers, you can add, you get 12. This actually, careful how you read it. It says 3 times the absolute value of negative 23 minus 10. So you got to multiply this. But before you multiply, you got to take the absolute value. So it's 3 times the absolute value of negative 23, which is 23, minus 10. 3 times 23 is, I don't know, 69, minus 10, and you would get 59. Okay? Determine what the numbers belong to. Okay, so 5 belongs to the counting, the whole numbers, the integers, and 5 is also a rational. Okay. Negative 14, it's not counting, it's not whole, but it's definitely an integer, and it's definitely a rational number. Negative 2.75 is a terminating decimal, a decimal that ends, right? There's not continue on and on forever and ever. So that becomes a rational number, only. Negative 3/8, it's a fraction. It's definitely not counting, it's not whole, it's not integer, but it's definitely a rational number. Okay, remember, rational number, we can write it in the form of a over b, where b is different than 0, not 0. Okay? Put these numbers on a number line. Okay, so to put these numbers on the number line, I would create a number line first. All right, actually, well, okay, horrible number line. Let's try that again, even a little bit better. Okay, so here's 0. Look on the right. On the right, your positive number is 1.15, so we need a 0. I'll put a 0 here. We need a 1. We need to go to 2 because 1.15 is going to fall between 1 and 2. 0 on the negative side, go negative 1, negative 2, and you're going to need a negative 3. So I'm just going to erase this and extend that number line a little bit. And you're going to need a negative 3. So let's do the easy one. The easy ones are my decimals, $1.15. So if that's $1.15, so here's 0, 50 cents, $1, $1.50, right? So I'm going to put these markers here just because I recognize them. $1.15, so definitely if you're counting, if you get to here's $1, $1, 1 cent, 2 cents, 3 cents, $1.10, $1.50 should be about here. Okay, a little bit more than $1, less than $1.50, so somewhere there. Negative $1.75, well here's $0, 50 cents negative, $1 negative, $1.50 negative, $1.60, $1.75 should be about here. Okay. So that's done, and that's done. -2 and 4/7 is going to be somewhere between -2 and -7. Well, 4/7 is a little bit more than half. So you can just approximate that and make, well, 4/7, right? Because if you had 7 pieces and I took 4, I took a little bit more than half. So this is 2.5, so it's going to be a little bit more than half. -2 and 4/7. You can always change the 4/7 to a decimal, okay, to give you a more precise location. -2 and 1/8, again, it's, imagine you had -2, so you're here already, and you have 1/8 of something, so you're going to go a little bit more down. So imagine if you had something and you cut it in 8 pieces and somebody took 1, you would have 2 and a little bit, so that's about here. You can think like that. Just, I'm not asking you to change or give me a precise value right now, so just approximate value. So putting on numbers on the number line, and you can now see that, you know, this is your smallest, second smallest, -1.75 and 115. Okay, am I missing a number? -2 and 1/8. No, I did that. -2.9. -2.9 is very close to 3. Sorry, I circled the wrong number. So it's almost close to 3, so it should be about here. -2.9. 3/4 and 5/6. Greater, less than. Okay, so you're going to have to figure out how to best approach this question. You can change them to a fraction where they both share the same common denominator, or change both of them to decimals. Choice is yours. I'll do it both ways. So let's change them to common denominators of that. Common denominator between 4 and 6 would be 12. 12. 4 times 3 is 12, so 3 times 3 is 9, so 9/12 and 3/4 is the same, but negative. 5/6, changing to something equivalent fraction as 12, would be times 2, so that becomes 10 on top. So there you go, -9 and -10. That still doesn't help you. Draw a number line. We don't need the positive, so this is 0. This is -1. So imagine from 0 to 1, right? Who's further away from 0? -9/12, -10/12. Well, -10/12, remember, 12/12 would be -1, right? Or 1. -12/12 would be -1. So 10 pieces. So if you had something, a whole of something, and you cut it into 12 pieces, well, 10/12 would be about here. And then 9/12 would be a little less. Okay, so if you place them on a number line, it's very clear that 9/12 is to the right, which makes it a bigger number, so you can say that it goes like that. Okay, the number on the right will always be bigger. Okay, you can change both of them to decimals, and I'll do that now. If you change the decimal, 3/4, and you divide 3 by 4, you're going to get 0.75, right? Because you have the zeros and do everything else. And then 5/6, actually, I'll just do it. 4 goes 7 28 times. 2 left over, add a 0, bring it down, and 4 goes to 25 times. That's a 0. So 3/4 is negative 0.75. In this case, it's negative, right? 5/6. 5 goes inside, 6 outside, does not go in. 6 going to 58 times, 48. 2 left over, bring another 0 down. 6 going to 23 times, 18. 2, go on and on and on. But we have enough information here where I know that 5/6, -5/6, equals 0.83 negative, right? So, all I have to do now is put them both on the number line. Okay, so again, this is 0. I don't need my positives, and this is -1. So negative 0.75. Well, if this is 0, this is 50 cents, right? 0, 25 cents, 50 cents, 75 cents, but negative, it's right here. As I keep going that way, 75 cents, 76, 77, 78, 79, 80, 81, 82. Here's my 83. So this is that, and this is my 0.83. Again, who's on the right is 0.75, so that's going to make it the bigger number. So that's going to go like that. Okay. Here, 23.45 and 23.4. I'd like you to do this. Now the decimals have their both the same decimal place value. So what's bigger, 23.45 or 23.40? Well, this one is a little bit simpler. Let's do the easy ones. Negative 15 and 16. Obviously, negative 15 is going to be less because it's a negative number. Negative number is always less than a positive number. Absolute value of negative 19 is 19. And is that greater than 19? It's not. Is that smaller? It's not, but they're equal. Negative 29 and negative 28. Well, negative 29 on the number line is more to the left, so that, okay, so if you put them on number line, let's just pretend this is 0 for a second. Negative 29 is over here, negative 28 is over here, right? So the number on the right is the bigger ones, which makes negative 29 the smaller number, so it's definitely smaller. And negative 5, 6, and negative 5.2. So 5 and 2/5, you can change it to fifth into a fraction. So negative 5 and 2/5, I'm going to stop here. It's going to be negative 5 point something. The 2/5 divide. 5 goes into 2 0 times. Out of 0, 5 goes into 24 times. So it's going to be negative 5.4. So now you got to decide if negative 5.6, and I'm going to change this to negative 5.4. Is it bigger or smaller? It's smaller because negative 5.6 is to the left of negative 5.4. Okay, so think about that. All right. The temperature on Friday was cold 12 degrees. On Saturday, the temperature was 20, then back up to 15. Okay, so one way of doing this is actually create a thermometer. Make sure you put all the numbers necessary. So you got 12, 11, right, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. I think that's enough. So if it was 12 degrees and it dropped 20, so it got really cold, so it's going to drop 20 degrees. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Drop all the way to negative 8. So on Saturday, Friday, it was 12. On Saturday, it drops, it become really cold. It became negative 8. And then on Sunday, it goes back up 15. So from negative 8, you got to go back up 15 degrees. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And it goes back to 7 degrees. A nice warm 7 degrees. Okay. And you can explain this using a diagram or with words, however you decide to. So create a number line and then put these two numbers on number line. So if that's 0 somewhere over here, this would be negative 7. And you can make this negative 7.2. So give it a lot of room. So one thing you can do to make life easier, if you want to understand this a little better, is think of money. If you think of money, this is negative $7. This is negative $7.20. So put a 0 here. And guess what? It won't hurt to do this. We're not changing any values, but it's just going to help us locate more numbers. So now think of numbers that are between negative 7 and negative $7.20. So the very first number, not the very first number, but in terms of decimal places, to the hundreds would be negative $7.01. Somewhere here in the middle, it'd be negative $7.10. Over here, negative $7.15. What about the one right behind 720? It would be negative 7.19. So again, you can put so many numbers here between 7 and 720. Okay, so just make sure that it's between these two, negative 7 and negative 20, 720. Explain why negative 5 and 5 are opposites. Well, if I draw a number line, and I get 0, 1, 2, 3, 4, 5, negative 1, negative 2, 3, 4, 5, negative 5. Why are these opposites? Well, they're opposites because from 5 to 0, the 5 spaces or 5 steps, 5 units, or better yet. And from negative 5 to 0, it's also 5 units. So whether you're standing on top of 5 or you're standing on top of -5 and you decide to go back to 0, you would walk 5 units. So they're opposites because they are both equally distant from 0. Okay, the distance from 0 is the same. Okay. To 0 or from 0. Okay. Put these in least to greatest. Put this in order from least to greatest. So the smallest numbers is the number on the number line furthest to the left. So imagine a number line, and you have to create a number. Which number would be all the way on the left would be -73. And as you move to the right, it would be -73. You would count down 72, 71, blah blah blah, -45, and then as you're counting down, you hit -8. Finally, you hit 0. And then 0, you start counting up again. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20, 21. There you go. So in order from least to greatest would be this. And the greatest number of all of them would be 21. So over here, I'm asking you to, you know what, I'm going to do 11 and 12 first, and then I'll go back to decimal. So number 11, explain how to find the opposite of -18. Well, here's 0, here's -18. And I'm going to put 18 over here. The opposite of -18 is 18, right? But I want to take the opposite of again. So if I take the opposite from there, it takes me back to -18. So the opposite of -18 is 18. But because I'm taking the opposite of that again, it takes me back to -18. Okay, so the opposite of -18 is -18. Find two numbers that have the same absolute value and explain how they're related to each other. Well, let me pick the absolute value of 3. That's 3 units away from 0. The absolute value of -3 is also 3 units away from 0. Okay, so they both are equally distant from 0. And how are they related? Well, they are opposites of each other. Okay, and we talked about that in the previous question. Now, this one, let me do the easy one. So 3 over 8, if you have to divide, I'm going to divide some over here. 3 divided by 8. 8 goes into 3. No, add a decimal, add a decimal, add a 0. 8 goes into 30. Oops, let me take that 0 out. 8 goes into 30. 0 here. 3 times, which is 24. 6 left over, bring a 0 down. 8 goes to 67 times, which is 56. 4 left over, bring a 0 down. And 8 goes into 40 5 times. So because it says if it's not a repeating, I want you to round to the nearest hundred. So 3 over 8 is the same thing as 0.375. But you want to round that to the nearest decimal, right? To the nearest hundredth, which means we only need 2 decimal places. Make a little cut here. And does the 5 have a little power to move that 37 up? It does, and you move to 38. So this is my final answer. 5 over 6, we're going to divide that. So I'm not going to divide all these for you. It's going to turn out, if you actually did the division, 5 inside, 6 here, and go on, you'll notice that would be 8.333. That 3 would be repeating forever and ever. So using a bar notation, you would write 0.83 like that. For fifth, the one was the fifth. Should be really easy for you to do. Okay, so think of $1 and you break it up into 5 parts. It'd be 20 cents, right? 20, 20, 20, 20. So 4/5, if you have 4/5 of $1, think of that. That would be 80 cents, right? So you can also, again, take your time and divide this. 5 does not go into 4, so add a 0. 5 goes into 40 8 times, 0.8, or 0, I'll just write 0.8. Okay, so 4/5 is 0.8. 2/3, it's going to be 0.666, and it goes on forever and ever, so we're going to put a decimal like this, and it's going to be like that, because the 6 repeats. 3/4, you should know this, 0.75. 3/7, I'm going to take and go back to this page to do 3/7. So the instructions said if it's a repeating, show what parts repeat with the bar notation on top, right? And if it doesn't repeat, use the round it to the nearest hundredth. So here's 3/7. So 3/7. I'm going to change that to a decimal. In order to change that, we're going to divide. Notice I made that a little longer than usual. I'll show you why. 7 does not go into 3, so we add a 0, add a decimal, add a decimal. 7 goes in, now add a 0. 7 goes 32 times, which is 21. 9 left over. Oops, what am I doing? Doing funny math. 7 goes, what am I doing? 7 goes into 34 times, which is 28. 2 left over, bring a 0 down. 7 goes into 22 times, which is 14. 6 left over, bring a 0 down. 7 goes to 68 times, which is 56. 4 left over, bring a 0 down. 7 goes into 44 times. No, 5 times. My God, must be Friday. 7 goes to 45 times, which is 35. 5 left over. Bring another 0 down. 7 goes into 50 7 times. 49. You might be asking, how long will I continue? Well, you'll see. And then 1 left over. Bring another 0 down. 7 goes into 10 one time, which is 7. You get 3 left over. Uh-oh. See this 3 here? It's the same thing as 3. So let's see what happens if I continue. Bring a 0 down again. 7 goes into 30. 4 times. Notice that the 4 just repeated itself, so it's 28. 2, bring another 0 down, only because I want to show you that if I keep continue, 7 goes in 20 2 times. Notice that the 2 repeats again. So if I actually continue, you would get 4, 2, and I'll change colors, 4, 2, 8, 5, 7, 1. And then it would go back to 4, 2, 8, 5, 7, 1. And it would keep doing that same thing, 4, 2, 8, 5, 7, 1. So 3/7 as a repeating decimal, it's going to be 0.42857. What part repeats? All these 6 digits repeat. So the bar notation goes over all these 6 numbers. Okay, as a repeating decimal, that's its equivalent. Okay, and we'll leave that at that, and that's review 1.